My beautiful little daughter, just like my beautiful wife, has a very bad problem. They won't shut the hell up. And I can't have this on my video. That's just women. Anyway, suppose this engine puts out 10 horsepower. Well, let's say it puts out 10 horsepower of energy. What the cylinder does is decide what the power band is according to the port timing. Okay, now that takes that power from the crankshaft and goes back to your transmission, which, when we step over here, is your crankshaft to your transmission. It breaks down the power into a reduction. It reduces the power to whatever you want the motorcycle to do. Say, for instance, that this is supposed to be a hill climber. It won't go very fast, but it'll have a lot of torque at the bottom end. Let's say we have our power as bottom, medium, and top end. All right, at that engine right there. Now, I've known a gentleman in Hawaii that has told me that he goes to a racetrack and he literally has to push the bike off the line with his feet because the gears are so tall, which means his gears are designated for just top speed. And once he gets going, gets into the power band, his top speed is phenomenal. I don't know, 110 miles an hour. I mean, that's pretty damn fast at 4 inches off the, you know, that far off the ground. It's pretty fast. What the reduction does is take the best of all power of the engine and applies it to whatever situation, say hills, roads, curves, all things like that, and considers the rider's weight when they design this. It's designed to work all over the world in all kinds of conditions. This engine looks like, oh, it's a little piece of aluminum. This engine probably has $10 million worth of research in it, and it keeps getting better. If you look at the Ruckus, the Metropolitan, which I don't know too much about that one, but the Ruckus engine is a beautiful engine. Anyway, on our gears, I'm going to show you stock gears compared to not stock. This is a stock final reduction. I believe it's a final reduction gear. Let's just say we have a primary and a secondary reduction. I'm going to call this a secondary gear. Okay. It has so many teeth on it. Now, it fits right here. Okay, with a shaft. This shaft right here, and I don't have a stock shaft. This is a stock shaft right here with a different tooth gear on it. If you look at, see if I can show it to you. Remember that the stock gear is on the right. You can see it has a lot more teeth. So if we put this into its slot right here, this is all hypothetical. What we need, let's say this is the secondary gear. We need the primary gear right here, but the primary gear has got to match these teeth. So we have a not stock gear, and we have two primary gears. We'll just call them primary. These are what fit on them. But let's say we have two primary gears. This is stock. This is not stock. This one came with that one. So we'll take the stock primary gear shaft, as you will, and we'll put it on here like this. Now, if you look closely, this stock gear is supposed to spin your secondary gear. As you can see, it doesn't do that because they don't match. So we take this off and we get the gear that matches it. You can see how much more teeth it has. All right, so we take this shaft, and we put it in. Okay, and then you can see that this gear matches this shaft. Now they're all different ratios. What happens is your stock shaft right here, or it fits in here like this. And there's a gear on that. Your engine spins your back clutch shaft and gear, which goes to your primary gear and your secondary gear. That determines your wheel speed according to the power that you have. And I have seen a chart that can tell you how many teeth that you have on both these gears, plus the diameter of the wheel. The diameter, all the way across the wheel, whatever wheel you're using, will tell you what your top speed will be. I've only seen it one time. I've never been able to find it again. These are just my layman's feelings on how they work. Layman's means, just to put it simply and not act like a physics expert on gear mechanics. So here's your stock one. This goes with the stock. This goes with the non-stock. Now when you buy racing gears that you want to install, you will get one of these and one of these. This is stock. Generally, the racing one will have more gears, not that many, but it'll have more. And correspondingly, your gear that fits on will be smaller than this. It will have smaller teeth because this has more teeth. You'll need to pull this through your cover case, and then you can put the gear in and you're fine. If you're going to change your gear on your secondary, on the shaft, you will need to take this to a machine shop and have them put in a 20-ton press this out, this gear off, give them another gear, whatever you decide, and press that onto the shaft. You can't do it at home, not unless you're, Joe Machinist or whatever, and then I guess you could. But this is a simple way, simple understanding of how this works, for me anyway. Now I'm going to take some pictures and put this on YouTube.